370 in dimes and quarters, so that's the total in both. 5 more quarters than dimes. D dimes and Q quarters. And we need to determine how many of both we have. Dad didn't straighten like the one. There we go. Alright, anyone have an idea or a guess as to what one of these equations might be?
Emma, you guys. Emma, we believe in you.
Chris, what do you have? Take a guess.
Alright, Emma, take a guess.
No, Chris, take a guess.
I'm not going.
Just guess.
Should I not go?
Can you guess?
Q equals 3.
Okay, so that's an incorrect guess, but
Okay.
thank you for guessing.
Thank you. Emma.
Mary. Say that one more time, a little louder.
Q equal 4.35.
So we're setting up the equation, not what it equals.
So it means E plus Q.
So that is almost right, but not quite.
Yeah, I was close.
Is it not? What did you say? No.
Setting up the equation.
Would one of them be 5 plus D?
5 plus D equals Q is one of them.
Oh, that's right.
Because this sentence, 5 more quarters than dimes, is if I knew how many dimes I had and I added 5 to it, I would get the number of quarters. So we have 1. We need 1 more. We know we need to use 370 as our total. And I said that Q plus D is not exactly right, but you are going to use those. What do Q and D represent?
Q's quarters.
Quarters and dimes.
What about quarters and dimes?
Quarters.
The amount. So what is missing? We have the unknown is the amount.
So the quarter will be 0.25 and dime will be 0.10. So then just do it from that way.
So every time we have coins, we need to include their amounts, what they're worth. Right? Now, do we need to solve one of these variables to get them by themselves?
Oh, wait, no.
No, because Q is already solved by itself. So what are we going to do with that?
We're going to put the Q into the 0.25.
Put Q in here. So 3.7, I'm going to leave off the zeros, it's okay, equals 0.25 times 5 plus D plus 0.01, D. And then what?
Distribute.
Distribute. 0.25 times 5 is what? 1.25 plus 0.25D okay, what do we do next?
Vector.
And when we do that, how many D's do we have?
No, like we add together. No.
Right here. It should be 0.35. Right, let's subtract 1.25. What is that? 3.7 minus 1.25. 2.45. And when we divide that, how many dimes do we get?
7.
7.
Oh, yeah. I was 4.
So if we have 7 dimes, and we know Q is 5 plus D, how many quarters do we have? 5 plus 12. Total would be 12. 5 plus 7 is 12. Yes. Right? Now, I do want to say this. Today we are going over the last type of. I started that sentence off wrong. We're doing the last way to solve systems by elimination. That means next class, today's Tuesday, Thursday, we're going to review. Monday is going to be your test. We're going to review a little bit, but Monday is going to be your test. No, I mean your test.
Wow. Already a week. You get like 9 minutes.
Yes. Okay, so I'm going to pass out your notes, but we're not going to start those notes until after lunch, so you can grab your phones. Alright, does everyone have one of these sets of notes? Somewhere on this front page, I want you to add this sentence. Add / subtract or multiply a common factor and add / subtract to eliminate a variable. Because that, along with this, is how you do elimination. So I am going to go ahead and fill this in, and you can fill that in after you finish writing that sentence. Make sure your equations are lined up. Add or subtract the equations to eliminate the variable with a common coefficient. Solve the equation for the remaining variable. Substitute your answer into either original equation. And solve for the other variable. So this sentence underneath that box and the sentence you're currently writing kind of go together. If there aren't common coefficients, multiply one or both equations by a number to make them common. So in general, you are either adding them, subtracting the equations, or you're multiplying one or both of the equations by some number so that you can add or subtract them. It'll make more sense when we actually do it. Anyone still need this? Okay, we're going to do the following problems together, and then you'll have time to do the others. So circle them. 1, 2, 5, 7 through 10, and 15. 1, 2, 5, 7 through 10, and 15. So those are the ones we're going to do together. Now, with all of these types of problems, elimination only works if they're lined up. So like in number 1, both of my y's are on the right, both of my x's and my constants are on the left, that's fine. Number 2, both my x and my y terms are on the same side, my constant is on the other. So they need to be lined up like that. If they're not lined up, you'll have to do that first. For number 1, we're looking for, do one of these variables have the same coefficient? Remember, coefficient is the number in front of your variable. Neither of them do?
Yes. The y.
The y does. So if one of them has the same coefficient, and that could be the same exact number, 1 and 1, or 1 and negative 1, either one. If they have the same coefficient, then we can eliminate them. So in the real world, what does eliminate mean?
You're dead. Like take out.
Take out, get rid of.
You're dead.
So if we eliminate a variable, what's going to happen to it? It's not.
0.
It's gone. It's gone away. We canceled it. Whatever. So we are going to eliminate our y variable since that has the same coefficient. Now, to eliminate it, we either need to add or subtract. So let's think about this. If we add these two together, will they cancel? No. So we have to subtract. Except when we subtract, we're subtracting the entire equation, not just one piece. So I'm going to do this step by step, and I would advise that you do the same thing until you get the hang of this. Y minus y is 0. 3x minus x, 2x. 4 minus negative 2, 6. We've eliminated y. Now we can solve for x. In this case, the only way to really solve for x is to move 6 to the other side. And then to divide it. So what does x equal? Negative 3. Remember, with all of your systems, you need 2 things for it to be a solution, the x and the y, or the answers to both pieces. So we need to take this and put it in one of these. It does not matter which one. I'm going to put it in this bottom one so that we can find y. What is y? Negative 5, which means our solution is negative 3, negative 5. Questions on that process? For number 2, do we have 2 variables with the same coefficient? X. Would we add or subtract these to eliminate it? Subtract. Now you're not always going to subtract, so I don't want you to think that. X minus x will give us 0. 4y minus negative y is 5y. 13 minus 3 is 10. Well, we don't really need that 0, so you can drop it. What is y?
2.
have y, now we can find x. Does not matter which equation we put this into. I'm going to put it in the bottom one though. So x minus 2 equals 3. If I add 2 to both sides, x is 5. So our solution is 5, 2. Remember, these are always x, y, even though we found y first. Questions on that one? Michael, put your phone up. On the wall. On the wall. Yes. Okay, good question. So Emma asked, why did we drop the 0 here but not here? In this case, 0 plus or minus anything is going to get the same outcome. If I add 0 to this, it's still going to be this. But here, because this equals 0, we need it so that we can solve for x. Okay. For number 5, are these lined up? No. This has x on one side and this has x and y. So we need to move this y to the other side so that they are lined up by subtracting. So if you see that, you should be looking for that. All the other ones were lined up, so we didn't need to. But that is your step 1 before anything else. Okay. Now, looking at both of these, do we have a variable with the same coefficient? Y. Could I add these two together and they cancel? Negative 3y plus negative 3y. That'd be the same thing as negative 3y minus 3y. Would they cancel? No. So in this case, I'm still going to subtract, but it's going to change a lot of our signs when we do. I do want to say this, because we've been subtracting the bottom from the top. You don't have to do it that way. If you wanted to do it the other way, you could. Negative x, I'm sorry. I should be looking at this one. I'm going to rewrite it. It's a 2. I was like, is that what that says? So if you wanted to subtract this one, you could, or if you wanted to subtract the top one, you could. It does not matter. Negative x minus 2x. Negative 3x. Negative 3y minus negative 3y is 0. And then 11 minus 10 is 1. This 0 here is not needed because it's very similar to 2. It's still going to be negative 3x. But in this case, we're going to get a decimal. That's okay. So x equals negative 1/3. Decimal or a fraction. That means yes.
So when you do that, does it matter if you subtract from bottom to top or top to bottom?
Nope.
No.
It does not matter.
So if you did
Because usually subtraction is not commutative, but in this case, they're both negative 3, so negative 3 minus a negative 3 is going to cancel either way you do it. So it does not matter. Right? We do need to put this back in. I'm going to go ahead and put it back into the original. when you move things around, you have options, so you can put it into the originals or whatever you move. It's going to work out the same way. I'm going to do that off to the side. So negative 1/3 equals 3y plus 11, and we need to solve for y. This becomes positive 1/3 equals 3y plus 11. How would we solve this for y? Subtract 11. So go ahead and do that in your calculator. 1/3 minus 11. What is that? 1/3 minus 11. I said, what's 1/3 minus 11?
Negative 1/3.
1/3. John.
Negative 32 over 3.
Sorry, say that again.
You said 1/3 minus 11?
Mm-hmm.
Negative 32 over 3.
Negative 32 over 3.
Negative 2.6.
So here, to get rid of 3, divide by 3, or really multiply by the reciprocal, so we don't have fractions within fractions. So I'm going to multiply both sides by 1/3. It looks a little messy because I'm running out of space. I'm sorry. Negative 32 over 3 times 1/3 would be negative 32 over 9. So your solution would be negative 1/3, negative 32 over 9. It's going to be some weird solution that has fractions. Questions on that one? Yes.
Here's how we got the negative minus 3y equals 11 versus the
So you just put negative.
Hold on.
Sorry.
It's confused about what?
I'm confused on how we got the negative x minus 3y equals that.
Subtracted 3y.
So you just took negative 1/3 and then put it into the other equation.
Put it into one of them. It doesn't matter which one. Okay. Or number 7. Do we have a variable with the same coefficient?
Yes.
In this case, we have both of them. So, would we add or subtract to eliminate one of them?
Subtraction.
Subtract. 3x minus 3x is 0. Negative 4y minus negative 4y.
No, it's minus 5.
It's not 8. Negative 4 minus negative 4.
0.
It's still 0. Negative 10 minus negative 13. 3. So really we have 0 equals 3. What does that mean?
Solution.
No solution. So when you go to solve these, if you see that the coefficient for your x and your y terms are the same, you're going to get no solution. If you were going back to your graphing, that would be, when you graph them, they'd be parallel. For number 8, do we have variables with the same coefficient?
Yes.
Which one?
Y.
So they're not the exact same, but they do have the same number, even though one's positive, one's negative. That's okay. Doesn't really matter which one we do because they both have that. So let's say we want to look at our x's. How would we eliminate our x's? We could add them. Because 2x plus a negative is really 2x minus 2x. So this is going to cancel. Y plus a negative y, those would also cancel. Negative 10 plus positive 10, that would also cancel. So we have 0 equals 0. What does that mean? There's infinitely many solutions. So if not just x and y are the same, but if the coefficient at the end is the same also, it's going to cancel and become infinitely many.
So all zeros is infinitely many and 1 0 is missing. But there's 2 zeros.
Like 0 equals 0.
Yeah, like 0 plus 0 equals.
I mean 0 plus 0 is 0.
Yeah.
So that would just be 0.
Oh yeah.
Right, for number 9, do we have 2 variables with the same coefficient? No. So this is a case where we have to multiply. Does not matter which one, but you want to eliminate something and multiply by a common multiple. So let's say I want to get rid of my x's. I would need to multiply this equation by negative 2. It could be by 2 or negative 2, yes? If you wanted to do your y's, you'd have to multiply by what? You can multiply this one by 3. What would you multiply this one by? 7. So when you don't have the same coefficient, you multiply so that you do. So let's say we wanted to multiply this by negative 2. But what you did at one side, you have to do to the other. So you're really multiplying the entire equation by negative 2. Now, you could have just multiplied it by 2, which would have been fine. In our case, because I multiplied it by negative 2, we're going to end up adding. If you multiplied it by just 2, you would end up subtracting. You would get the same thing now. It just depends on the number you choose. Right? So here, to get rid of x, we can add these two. That should always be the question. How can I eliminate these, adding or subtracting? 2x plus a negative 2x is what? 0. Negative 7y plus negative 6y. That's the same thing as negative 7 minus 6. Negative what? 13. Negative 13y. And then negative 1 plus negative 12. Negative 13 also. So y is going to equal positive 1. Right? Which means we can go back and put 1 into this equation or one of the originals, does not matter. to find x. Which one do we want to put it into? The top one, okay. So we have x plus 3 times 1 equals 6. It's supposed to say equals 6. And, so x plus 3 equals 6. My pen is not writing what I write. That should just say 3. It looked like a negative, but it was just 3. What does x equal? 3. So our solution is what? 3, 1. Questions on any of these? Right, for number 10, do we have a variable with the same coefficient? No. So what variable do we want to eliminate? Let's choose that first. Y, okay. If we want to eliminate y, we need to multiply this equation by some number and this equation by some number that are common multiples.
You multiply the top one by 7 for y, so you multiply the top one by 4 and the bottom one by 3.
You can multiply one of them by a negative, or you can multiply both of them by a positive. It does not matter. Which means you will have 2 new equations and need to write both. 12x plus 12y equals 36. And 15x plus 12y equals 30. Now we're trying to get rid of y, so would we add these or subtract these? Subtract. (12x minus 15x) negative 3x. 12y minus 12y will give us 0. 36 minus 30 will give us 6. What is x? Negative 2. Right, and then we need to put that back into one of the equations. Which one do we want to put that into? So it could be either of the originals or either of the ones we just found. Which one? The first one? Okay. So if we put this into the first one, I'm going to put that in 11 because I'm running out of space. 3 times negative 2 plus 3y equals 9. So negative 6 plus 3y equals 9. How do we solve for y? Add 6 to both sides. What is y? 5. So our solution is then negative 2, 5. We have questions on that one. Right? 15. What would be the first step? See if they have the same coefficient. Do they? No. What's the next step? Multiply what? You choose. Okay, so if we're solving for x, what would we multiply? So here, because this is already a negative, we don't need to include a negative, but multiply the top by 5 and the bottom by 4. So pay attention to that also. If it has a negative already, you're just creating more work for yourself if you add in another negative. So 20x minus 8y equals 25. Negative 20x plus 12y equals negative 4. What's the next step? Subtract the entire equation. 20 minus negative 20 gives us 0. Negative 8 minus 12 is what? Say that again, sorry. Not 21. 20y. Yes, but negative. And then 25 minus negative 4. 25 minus negative 4. 29.
Okay, one. What?
Are you guys okay?
Oh, yeah.
I think this is the last one that has fractions or decimals. I just want to check.
Is that negative 8, right?
No, this is the last one that should have fractions or decimals. What did you say?
Is that negative? No.
No, he counts it as a sliver.
Negative 1.
Why?
Right here. Yeah, that should definitely be negative 10. Okay, that's going to change this. Negative 10 minus 12. Negative 22. This one is supposed to be a decimal, it just wasn't the right one we were about to get. Okay, so y equals negative 29 over 22. It doesn't like me today, apparently. Okay, and then we need to put that back into one of the equations, does not matter which. Which one do we want to put that back into? The first one? Okay. I'm trying to scroll up, but it's not working. This is the first one. 4x minus 2y equals 5. Put this in your calculator. Negative 2 times negative 29 over 22. Negative 29 over 10. 4x. 4x plus 29 over 10. And then we would need to do what? Subtract this over. So do 5 minus 29 over 10 in your calculator. I don't know if that is right or not, but that's the decimal you got. 21 over 10 is the same as 2.1. Yes. Okay, and then divide 2.1 divided by 4. Change that back into a fraction. What is 0.525 as a fraction? What is this as a fraction? Type in your calculator. What did you say? 21 over 40. That sounds accurate. I don't know off the top of my head.
Wait, is it negative?
No.
Okay, no, it is 21.
21 over 40.
Yeah.
Okay. So if you start with fractions, end with fractions, if you change this to a decimal, then you could keep decimals. What is this as a decimal? Just so we have it. It's going to be something weird because it's over 22. Say it louder. 3181. We need just about that. That's okay. Okay, so you could write your solution as 0.525, comma, negative 1.3181. Or as your fractions, 21 over 40 and negative 29 over 22. Either one of those. Just don't mix and match. Right? So you have, yes. Where? Here. So, because it was negative, no, we were supposed to add. Because if we subtracted, that wouldn't have been 0. We definitely should have added. So, I'll go back and fix that so you have it on your notes. You still would have got weird, ugly fractions, but yes, so that's what we're supposed to add. Thank you for catching that. Erase that problem. You don't need to refix it right now, but we solved that wrong. Yes.
Is there going to be any questions like this?
Yes, it's something.
With decimals.
Yeah,
Yeah, my
because,
question.
like this crazy manifest.
Why? Yes. I'm sorry. Yes. Right? Accept 15, disregard 15. I'll fix that. I want you to work on the other problems. and you have until the rest of class to do that. So work on the other problems. If you have questions, I will be around. No, it's not homework, but I'm not going to check it either.
No, you cheated. Wait, what's this
Okay, my
You suck. I won. Okay. No, you don't know how to play. I beat you 8 times. I beat you like 10 times.
Guys, get my down.
Oh, I was too busy talking. Oh, I need to do my work. You guys are talking. I just have 2 more to do.
I don't know if mine works.
I'm so sorry. You already.
I don't know how to explain it. I get it, but
I get track. No, I don't
you're hurting my water.
You're like these ones.
No. We all did them.
Oh, I already got it. I'm on the floor.
You did it all?
What's